Welcome back. Now let's talk about obtaining covariance matrices using I, the identity matrix, and J, the matrix of just ones. Now, if you recall, there's a few steps, or there's a few different ways you can do it, and each one has a few steps. So let's try the first method now. We have a 4x3 matrix of raw scores. So matrix input, the raw scores will be called X, and X has the values of 8, 5, 6, 7, 4, 11, 6, 5, 10, and then 3, 2, 9. And then let's look at that to the left here. Okay, it looks like I put that in correct. The next step is to obtain deviation scores. So we're going to do matrix input X bar. And if you recall, what we do is to obtain deviation scores is subtract the mean of each variable. So the mean of the first variable is 6, the next one is 4, and the next one is 9. So we're going to have that 6, 4, 9 going down each column. And we need 4 of these. So let's take a look. Okay, we have that correct. So let's get the deviation scores. Call it little x equals, so it's going to be this big X minus X bar. So we get 2, 1, negative 3, 1, 0, 2, 0, 1, 1, negative 3, negative 2, 0. So the next step is to pre-multiply this by its transpose to get the CSSCP matrix. If you recall, the CSSCP matrix would be called B, and you can see video 3.8 on that. So we can do matrix B equals, it's going to be X transpose times X. And let's see what we get. We do get 14, 8, negative 4, 8, 6, negative 2, negative 4, negative 2, 14. And once again, it's a symmetric matrix, so I'll just give you the lower left triangular portion. So that's one way to do it. There is a second way that we did it. So we are going to calculate the centering sum of the squares and cross products matrix by taking the raw sums of squares and cross products matrix and subtracting it from, subtracting from it a matrix that corrects for the mean, which will be this TM transpose. So we can say the SSCP is X transpose times X, and TM transpose, this centers it, and T is the column sums, and M is the means of columns. And let me bring that down so you can see it. So let's input those. Let's do T first. T is going to be 24, 16, and 36. Those are the column sums, so let's take a look at that. Okay, and then we can do M, and M is 6, 4, 9. Those are the means of the columns. Alright, so in this case, let's let the matrix D equal the CSSCP matrix, which equals X transpose X minus T M transpose. And I'm just going to copy and paste. What I'm going to do is add multiply here. And let's take a look. We should get the same thing, which we do. 14, 8, negative 4, 8, 6, negative 2, negative 4, negative 2, 14. Okay, that was probably the longest way, maybe the hardest one too to understand, but there is, luckily, a really simple way that we can do in pretty much just one step. And for this one, we're going to let C equal CSSCP, which is equal to large X transpose times small x. C equals X transpose times our small x, which is our matrix of deviation scores, and let's take a look at that. And we should get the same answer, which we do, and that is just one really, really simple, easy way to do it. I recommend if you ever have to do this, use that one, especially in Stata. It's just really simple. And those are the different ways you can obtain covariance matrices using I and J.